if you introduce some parallel code in an existing application, when and why we must use parallel tools and our development cycle? At the beginning, the middle, at the end, your opinion?
I think all of the above. As you're building a parallel application, one of the things that we thought as we were designing the technologies that we shipped in Visual Studio 2010 is that you can't have a programming model without tools. It just doesn't work, and it doesn't help people be productive. So that's sort of one of the core tenets we set for the team is like, look, we're not going to go off and build PPL or TPL or whatever it is without the ability to easily debug these technologies, without the ability to visualize performance in the profiler and understand how performance is relative to how it could be. And then there are lots of opportunities for other tools as well. And so we feel really strongly, and that's why we invested in both tools and programming models. And I think going forward, you'll see us continue to do that. In terms of how developers should think about it, I mean, it tends to start with the programming model. People tend to think about, okay, how can I work this into a task-based architecture? How can I use P-Link? How can I use agents? So a lot of times the first place someone's brain goes is with the programming model. But once you start to write this code, and I guess that's the beginning of the beginning phase, once you kind of get into the middle phase, where you're doing this fast, like I'm coding, I'm trying it out, I'm debugging it, I'm trying to see how things work. When you get into that phase, the debugger is very helpful. And I think the debugger is helpful in a couple different ways. One is in Visual Studio 2010, the debugger helps raise these task abstractions to be first-class citizens in the debugger. So they're not these weird things that are in the language, but not really. Someone really dropped something. That are in the language, but not really in the tools. So it used to be that we would write, for example, OpenMP as another programming model. People would write this great OpenMP code and then go to debug it. And so when you wrote the code, it looked like, hash OMP parallel for, whatever in your code. And then you debug it and you're in threads and call stacks and, stack frames and local variables. And you've got all this information in the debugger, but you don't have anything that helps you map the code you wrote to what it looks like in the debugger. And in between, it becomes very obvious that there's this black box resource manager, this black box runtime that is creating some kind of task thing, and it's scheduling them and executing them and mapping them to resources, threads in this case. And unless you really understand how that black box works, it becomes very difficult to edit your code or debug your code unless you really understand how things drill down and dilute to what happens in the debugger. So that's one of the core things we did in Visual Studio 2010 is now there's a window. You can see, these are the tasks that got created. I either created them myself manually by saying, task factory start new, or task group run if you're in C++. Or I created them, they were created underneath the sheets for me by using a parallel.4 or parallel_4 in C++. So you can see this. The other way that the debugger and tools help is by helping you cope with the now vastly increasing levels of parallelism and just state that you have to manage. And it used to be, as a developer, we'd have to keep, still is in many ways, you have to keep all this state in your head, right? Particularly when you're debugging, it's like you're going down into the rabbit hole, and you've got to keep track of all this mental state that's happening as you're going down this rabbit hole. And a lot of times people will keep a little pad of paper, a little sticky note. They'll write down addresses as they go through this rabbit hole so they can kind of, and as they're popping back up, they'll kind of, okay, this address means this and this means this. And, as you have, 2 threads or 5 threads or 10 threads, you can kind of manage that. As you have a dozen or 2 dozen or 3 dozen or 100 threads, you just can't manage that anymore. And so one of the ways that we help you manage that in Visual Studio 2010 is the parallel stacks view, which is this idea that we can take all the parallel contexts at once, whether you're viewing via a threaded view or a task-centric view, but we can stitch all these call stacks together. And so you can see, when I stop my program at a glance, what's everybody doing? Where are all these tasks? Where are all these threads? Where are they executing? And it helps you kind of get more of an all-up idea, and then you can say, okay, what if I go down this path? What do my locals look like? What if I go down this path? Where are my deadlocks? You can start to invest, and you find interesting avenues for investigation. There's a lot more that can be done here because the problem's only getting worse as we, down the road, as we add GPUs to the mix or other kinds of vector accelerators. The levels of parallelism that we have to cope with are even more great. And so we're going to come up with greater and greater ways for developers to manage that kind of concurrency and that kind of mental state that they have to keep track of. So that was, I said a lot about the middle phase. Now as we move toward, maybe more toward the end phase, you're thinking about things like performance optimization. All right, so I envisioned how I was going to write the code, and I started writing code, and then I have my write, edit, compile, debug loop. And then as I move on, I'm trying to see, does this meet my performance goals? And for that, we did some work in the Visual Studio Profiler. We have some technology called the concurrency visualizer. And one of the things that we find most profilers are really, really good at is giving you data. Profilers are they're excellent at collecting all this data, whether it's some kind of hardware counter on the CPU, or whether it's some kind of instrument that's keeping track of what's going on at various intervals in time, or sampling at various intervals in time, or whatever. But typically the profiler experience is information overload. And then you have these Jedi wizards of profiling that know how to interpret all of this information. One of the ideas we had for this version is, gosh, is there a way that we can help people make sense of their program by showing them pictures? And so it's this kind of Rorschach ink blot test of, okay, let me show you an ink blot of your program's execution, and you tell me what you think it means. And what we found is that there are a handful of performance archetypes that you can look at in the profiler, and you could see, to me that looks like a load imbalance. Like I've got one piece of work finishing here, and then it takes a really long time for the rest of the work to finish. So I'm not getting balanced execution of my program across all the resources. Or you can see things like oversubscription. Gosh, my program is spending a lot of energy switching context between this thread and that thread, and I've obviously got way too much stuff going on this system, and you can see that in a picture very clearly. Other things you can see are things like lock contention or lock convoys, where, gosh, I've got this 8-way computer, but for some reason only 1 or 2 cores are in use at any one time. And that's very typical of, I've got a bunch of things that are just kind of queued up waiting at locks, waiting to get access to some shared resource. And so these are all things that are pretty easy to pick up without looking at spreadsheets worth of data, but instead just kind of looking at that ink blot, looking at the concurrency visualizer, and seeing what's happening on the system. And so you'll see us try to do more of that. The key thing that we want to do is, one, help people discover things they don't already know about their program. We find that a lot of energy sometimes goes into confirming what we already know, and we'd rather help people discover new things, but then also make that actionable. So once you've discovered something you don't know, how do I do something about it? Why do I care, and how do I do something about it? And so from that standpoint, what you'll see is connections back to source code. So once you've had an opportunity to kind of drill in, and I've identified, this is the piece of my profile that looks a little bit weird, here's the picture that's weird, I can double click, and I can one, learn more about where I am and what it's doing, but then it will take me back to the code and right on the line where I know I can, here's the lock that I know I need to do something about because it's highly contended. So that's my kind of long-winded answer for going through the different phases of the development cycle and why tools are really important.
Okay, it's a great methodology.